Hi, welcome to Tennessee Technological University. I'm Melissa Geist, and I'm a faculty member in the School of Nursing.
And I'm Janet Kuntz, and I'm a faculty member in the chemistry department.
What we're going to talk about is some of the different solutions that you might see as a nurse in the hospital. So we're going to spend most of our time talking about sodium chloride solution. This is a 0.9% sodium chloride solution, and its common name is normal saline. And in the emergency room, which is where I work, we use this pretty much as our main solution. It is isotonic, and we'll see what that means. And so this is it's a great solution to rehydrate patients and just to maintain hydration status. We also have, just as a comparison, a 5% dextrose solution. This is actually called D5 half normal saline. And so it's got dextrose in it. We see this in the pediatric population. A lot of times in pediatrics they need the dextrose really just to feed their cells, but we also need to make sure we get the fluid in as well. So this is a dextrose solution. And then hanging here on our IV pump, so these solutions generally are going to run through IV pumps so we can control the rate. This is a solution called lactated ringers, which is also considered isotonic, but it has a very different chemical makeup than the isotonic sodium chloride solution. So we are going to show you chemically what these solutions look like, and then we're going to have you work out some mathematical problems.
So now what I want to do is show you how to make a normal saline solution. A normal saline solution is a 0.9% weight volume solution of sodium chloride. What a 0.9% solution means is there are 0.9 grams of sodium chloride dissolved into 100 milliliters of solution. Grams, it's a unit of mass. So to take the mass of 0.9 grams of sodium chloride, I'm going to use a balance. I'm going to use a weighing dish, tare the mass of the weighing dish to where now my balance reads 0.0 grams. Then I'm going to add the sodium chloride until I have 0.9 grams. This is the same as 900 milligrams. And I need to make a 100 milliliter solution using deionized water. So deionized water, pure water. And I could use this measuring cup. This measuring cup, you can see 100. It's a little bit less than half of a cup of liquid. But this isn't going to be very precise. It'd give you an approximately 0.9% solution of normal saline if I filled it up to this 100 mark. But I'm going to use, in chemistry, I either use a graduated cylinder or a volumetric flask. The volumetric flask will give you the most precise solution. I'm going to use a graduated cylinder. Add my salt, water, and then swirl until all of the sodium chloride is dissolved. Then add water until I have 100 milliliters of normal saline.
Janet, I see as a chemist that you've made up this 100 milliliters of solution, but the problem is my patients need a liter of solution. So what are we going to do, because that's just not enough?
Well, I'll ask you, how much sodium chloride do I need to make a liter of solution?